Okay, Math Model Semester 2, Lesson 131, the study of graphs of exponential functions. All right, keywords in your own words, write a definition for each key term listed below. The first one is the x-axis, and the x-axis is nothing more than the horizontal axis in the coordinate system. Bless you. Okay, the horizontal axis in the coordinate system, and it runs left to right. Bless you again. All right, so this right here will be an example of the x-axis. So that brings us to our first main idea. The base of an exponential function determines if the graph is going to increase or decrease. And the base is represented by the letter B. So we're going to write each of these numbers in the correct column of the chart. 0, 1, imaginary numbers, negative numbers, positive numbers, and real numbers. So once again, an exponential function is just a function with the form y equals ab raised to the x power. Keep in mind that the base is a number in exponential form, and it appears beneath the exponent. That's what's important about the base. Okay, and the base can be any positive number or any real numbers. Okay, positive numbers could be anything that's on the right side of the x-axis, so think about it as anything from 0 on in that direction. So that's a positive number. So 1, 2, 3, 4 positive numbers. But a real number could be rational numbers or irrational numbers. So a real number could be 0.5, or it could be like pi, 3.14. Those are all real numbers. Right. So values that the base cannot be, it cannot be a negative number. It can't be imaginary numbers. Imaginary numbers are just what's created when you have a negative underneath a radical. It can't be 0, and it can't be 1. Whoops, that disappeared. There we go. So it can't be either of those values. Okay, so write decreasing or increasing in each blank to describe the graph. So if B, the base value, is greater than 2, then it is increasing. And if it's if it's greater than just 0, then it's decreasing. Look at the graph on the next page to make it make a little bit more sense. Now remember, when we look at graphs, we read them going from left to right. So this graph here, the first graph, is going to be increasing because looking at what happens with the line as we go from left to right, this graph is going up. So that's an increasing graph. This one here, if I look at the graph going from left to right, this line is actually decreasing because it's going lower. All right, so the main idea is that the graph of exponential functions have certain features in common. So if we look at the function that's on the left highlighted in green, it says f of x is equal to b raised to the x power. So the shape on that graph is always going to be a curve. And here's what you got to know. It increases if b is greater than 1. It decreases if b is greater than 0 but less than 1. So an example there would be either a fraction like 3/4. Whoops, that's not coming out right. Let's see. 3/4, or I don't know, 2/3, or even a half. All right, that would be an example of decreasing. The y-intercept happens to occur exactly where 0 and b intercept. So it's just like the graph of a line. The other known point on the graph is going to be 1b, and that is where b is the base of the expression. The horizontal asymptote is the x-axis, so the line will get very close to this x-axis here, but it won't actually touch it. So it could be something like that, or it could be something like that. It should never touch it though. All right, the domain is going to be all real numbers, and the range is going to be all positive numbers. Okay, and so the function where f of x is equal to a times b to the x power. B is going to be like the other side, greater than 1, and it's going to be all values where b is greater than 0 but less than 1. The asymptote is, the y-intercept is going to be wherever 0, a is located, and you'll be able to determine that when you look at an equation. And then, oops, drew the line to the wrong spot. Right there. All right, and then another known point is 1 comma AB, where you multiply AB. The domain is going to be all real numbers, so it'll have that in common. And the range is going to be all positive numbers, where y is greater than 0. Okay, here you have an example of both of the two equations we talked about. On the left side, you have y equals b to the x, and on the right side, you have y equals ab to the x power. So what I went ahead and did is put it in a calculator so you can see the differences. So here's y equals 2 to the x power, and we just press graph. And you see your graph looks like that. And then over here, we'll press graph. So you can see it's a little bit narrower, but they have some of the same properties. So what you see is your y-intercept over here. It says that it's 0 and b, so it actually crosses at 0 and 2. And over here, our y-intercept was 0 and a, so this one actually crosses a little bit higher at 3. And then another point, it says 1b. So if you look at the table, b is 2, so at 1 and 2 you have a point. And over here, if you look at the table, at 1 and 6, because 2 times 3 is 6, you have another point. All right. Okay, so this concludes our lesson. Hopefully you found it helpful. Remember, I am here to help you. If you need help with anything, do your practice problems. It'll help you as well.